Perfect. So hi everyone, welcome and thanks for joining us. Today we'll be discussing Azure Firewall Private IP DNAT and its use cases. My name is Andrew Mathu. I'm a product manager in the Azure Network Security Customer Experience Engineering team. And with me, I also have my colleague, Gustavo Modena. We're happy that you've joined us for this webinar, and we hope that you're going to find it beneficial. So in our agenda today, we'll start with an overview of Azure Firewall, followed by its features and SKUs. Then we'll dive into network address translation, specifically focusing on Private IP DNAT and explore its use cases. We'll then run through a demo, and then towards the end, if we have time, we'll also respond to some of the questions that you posted in the Q&A. So please feel free to post your questions, and also have team members who are at hand to reply to your questions. So to start us off, we'll get started with an overview of Azure Firewall. So Azure Firewall, just as a reminder, this is a cloud-native intelligent network file security service, and it provides threat protection for your workloads running in Azure. It's fully stateful, firewall as a service with built-in high availability and unrestricted cloud scalability. So here we can see some of its key benefits, which include network and application filtering, threat intelligence, the ability to deploy and scale in minutes, and also it supports east-west and north-south traffic filtering. In terms of its advanced threat protection capabilities, which are available in the Azure Firewall Premium SKU, it has the ability to offer support URL, FQDN filtering. It's able to detect zero-day attacks and offers protection against day zero attacks. It also has an IDPS engine, which has over 60,000 attack signatures, offering fast and reactive pipeline to detect and prevent against attacks. It also has threat intelligence and web categorization support. So Azure Firewall can be deployed in various scenarios to enhance your security and connectivity. And here you can see the three Azure Firewall use cases. So the first use case, it can be used in a VNet deployment to secure traffic between spoke VNets, subnets within VNets, and traffic to the internet. It can also be deployed in a virtual WAN, that's a secure hub, to secure traffic between VNets, branch offices, and also cross-hub. Additionally, this is the third use case. It supports a forced tunneling mode, where the internet breakout is through a third-party firewall deployed on premise or elsewhere. We have three Azure Firewall SKUs or versions, and these are the basic, standard, and the premium. So starting from the left, going to the right, the basic SKU, this provides layer 3 to layer 7 filtering, and it's aimed at SMB customers, small to medium-sized businesses, and this is at an affordable price point. So it's recommended for these customers with throughput needs of up to 250 Mbps. We then have the standard SKU, and this supports enterprise features such as threat intelligence, DNS proxy, custom DNS, and web categories, and also provides layer 3 to layer 7 filtering and threat intelligence fields. This is for the threat intelligence from the Microsoft cybersecurity intelligence team. And then the third SKU, this is what we call the Azure Firewall Premium SKU. And this is recommended to secure highly sensitive applications, organizations, such as those who are in the payment processing. It supports advanced threat protection capabilities, such as like malware and TLS inspection. In terms of the actual feature that each of these SKUs has, we can see them listed here in this feature comparison table. So we can see similarities across these 3 SKUs, and that's for the first 3 feature categories. So for L3 to L7 filtering, in terms of reliability and performance, ease of management, and the only difference now, as I mentioned, being in terms of the throughputs, and this is under the reliability part and performance. So for basic, we see it's up to 250 Mbps. For standard, it's up to 30, and for file premium, it supports up to 100. In terms of also fat flow support, we do see some differences with these throughputs listed here. In terms of enterprise integration, we can see standard and premium. They support all the features under enterprise integration, where we have our login to the SIEM, we have the web content filtering, but these two are not supported under basic. That is the web content filtering and the DNS proxy. For the advanced threat protection features, like I mentioned earlier, these are available within the Azure Firewall Premium SKU. So with this, you're able to have TLS inspection, you have IDPS, and you have URL filtering on the full path. So this lists the differences between these SKUs and also geared towards the specific customer segment I had mentioned earlier. So with that overview of Azure Firewall, since we've reminded ourselves about it, in this next section, we're going to take a look at network address translation, just setting the context before we go into the main topic, which is on the Azure Firewall Private IP DNAT support. So as I'm all sure, we've all heard about network address translation. We've interacted with it in one way or another. So NAT, this is a method we use to map an IP address space to another by changing this network address information in the IP head of packets as they pass through a routing device. And this routing device could be a router, it could be a firewall. And we know in terms of the benefits and the use cases of NAT, why it came about is first of all for enhanced security. So it does this by hiding the internal network structure from external networks. So we don't want our internal networks being exposed. And this, of course, makes it difficult for potential attackers to target specific devices within the network. NAT is also used for IP address conservation. And this means it helps to conserve the limited supply of IPv4 addresses. In as much as we also have IPv6, we still have IPv4 addresses being used. And this it does by allowing multiple devices to share a single public IP address. We also have network management, where NAT enables easier management and flexibility. So it simplifies the process of adding new devices to the network and managing IP address assignments. Then finally, we also have cost efficiency. And then this comes about when we reduce the need for multiple public IP addresses. So this helps to lower the costs associated with the IP address allocation and management. So having taken a look, refreshed ourselves about NAT, in this next slide, we take a look at Azure Firewall Network Address Translation, Azure Firewall NAT. So Azure Firewall, when traffic passes through an Azure Firewall, this Azure Firewall can perform NAT to translate the source of the destination IP addresses and the ports of these packets. So Azure Firewall has support for 2 types of NAT. The first one is the source NAT, and then we have the destination NAT. So source NAT, this will modify the source IP addresses of outbound traffic to a public IP address, the public IP address of Azure Firewall. So all outbound virtual network IP addresses are translated to the Azure Firewall public IP. For destination NAT, what we call DNAT, this translates and also filters inbound traffic to Azure subnets or also internet traffic between private networks within Azure. So DNAT, this is applied within DNAT rules, and these are applied in priority before network rules. So they're always processed in terms of the rule hierarchy of the Azure file. We'll have the DNAT coming first, then the network rules, then the application rules. So if a match is found within the DNAT rules, that traffic is translated according to the DNAT rule and allowed to go through by the firewall. So having taken a look at that NAT and also the supported NAT types within Azure Firewall, in this next section, we're going to take a look at the support that Azure Firewall has on a Private IP DNAT. So to get us started off, just to give a background of how this came about. So previously, DNAT rules were only supported on the file's public IP addresses. So if you wanted to do a DNAT, configure a DNAT rule for inbound traffic going towards your internal resources, that you wanted external access to those resources, you could only do that through the Azure Firewall's public IP address. However, now with this new release, with this new feature, and also the basis of our webinar today, Azure Firewall now also supports rules using its private IP addresses. And this enhancement came about from the challenge that the customers were facing in establishing communication between overlapping networks in Azure due to the lack of NAT functionality on the private IP address. So this feature is currently now in public preview, and with it now, we now have the capability to allow seamless communication between overlapping networks, and with this, we're able to also secure connectivity in hybrid networks and environments. And you can see now with this enhancement, we have two main use cases, which we'll also take a look at shortly, which is communication between overlapping networks and access to non-routable networks within Azure. So you can just see on the diagram here on the right what this looks like, pretty straightforward. So if a client wants to establish communication to a server, and in this case, we are NATing on the private IP address of the Azure Firewall, it is able to do so. So it's going to use the firewall's IP and port, which is defined in the DNAT rule. So you can see here, our firewall will have this. This is the private IP address of the file, the 10.10.068 on port 80. The file will process the DNAT rule and will translate the destination using the server's IP address. So with this, we're able to establish communication between our client and server. So just a very simple high-level example of this, how this works. Just to add on to this, this is currently supported within for Azure Firewall in the SKUs that we saw earlier within Premium and Standard within the public preview. And in terms of the documentation, if you want also after this webinar to take a look at the scenarios that we've published, which we'll also go through in a short while, you can check out this blog here. And we also have a tutorial on how you can be able to configure DNAT using the Azure portal. So some of this you can also take a look at after this session. So moving on to the next section, after that introduction and getting really to understand the background, I will take a look at the first use case. And this is to allow communication between overlapping networks. And the most common scenario for this is when our customers, when you're integrating with new partners or during mergers and acquisitions. So organizations, they usually face the challenge of overlapping IP address spaces. So this was the first use case scenario with which now the private IP DNAT support came into being. And now with this enhancement, we'll get the benefit of simplifying the network integration and also ensuring uninterrupted communication between these different IP addresses. So you can see here on these diagrams, we also have this in the blog, which I shared. This is the scenario for overlapping networks, which you use to demonstrate this. And in this use case, there's a requirement to deploy 2 Azure files. And the primary function of the first file is to mask the original source IP by performing an SNAT, and this will allow the second file to correctly distinguish between the source and destination IP addresses. In this scenario, we have the overlapped IP networks. So in this case, just for us to go through this scenario, you can see here we have 2 virtual machines, VM2, VM4. They have the same IP address. Within this scenario, we now also have 4 virtual networks, VNet 1, 2, 3, and also 4. Now, VM2, you can see from this red line, which shows the flow of the path that it will take. VM2 wants to communicate with VM4. But you can see now in the previous, like I mentioned before, the private IP DNAT came into be, this would have caused a challenge. The communication, of course, would not have been possible. So in terms of the flow, just to go through it, what happens, the VM2 will request access to the first file, private IP address, which is the 10.10.068. In our example, we're using port 80. This can be any other port in a real world scenario. After that request is done, Azure Firewall 1 will process the DNAT rule and send this request to the private IP of Azure Firewall 2, which you can see here is 10.10.2.4. Azure Firewall 2 will process the DNAT rule and send the request to our VM4. So in this case, we're able to establish that communication between our 2 overlapped networks, our virtual machines. In terms of how the DNAT rules look within the Azure Firewall, you can see here on this first part, this is the DNAT rule on our Azure Firewall 1. So it's listening on this port, example using port 80. This is its private IP address. The translated address or FQDN is going to be the IP address of our second file, the 10.10.2.4, which you can see here, they correlate. The translated port is port 80. In terms of the second file, you can see it's listening again on port 80. This is its private IP address. So this is the destination whereby this traffic is being sent. This is the private IP of the virtual machine 4, and it's listening on port 80. So with this, we've seen the first use case, how we're able to establish the communication between these overlapping networks. For our second use case, this is for access to non-routable networks in Azure. So for this one, this is where a resource from a remote network is trying to communicate to another resource sitting in a different VNet or vice versa, and there's no direct routing between those networks. So the main use case, as you can see here, is in hybrid environments where on-premises data centers, they'll need to connect to Azure, and there's often a need to route traffic securely between private resources over non-routable IP addresses. So we don't want our traffic being exposed to the public, and then of course there's no route to it. So with this, the benefit that of course comes and came about is you're able to enhance the security and connectivity in these hybrid network setups, be able to ensure that internal communications remain protected and efficient. So enterprises, of course, like I mentioned, they would probably like certain workloads hidden without exposure over public IP addresses for security reasons. And then they have now that Azure file that they have deployed, or they have deployed those workloads behind an Azure firewall. So in this case, with this enhancement, the traffic from the on-premise network will arrive on the Azure Firewall private IP address. With the Azure Firewall, the file private IP address as the destination, and the file will perform a DNAT to the backend server, as you can see here in this diagram. So again, this is from our blog where we had illustrated this, shown this as an example where we had a remote network connected via VPN to Azure, and in our backend we have a virtual machine running within one of our VNets. So what happens, as you can see within the flow, our remote virtual machine one, and this is also simulating, this could be on-premise connecting to Azure. It will request access, and this is to the private IP address of the Azure firewall, and we used an example in this case of port 80. So this request will go through our connection. In this case, it's VPN in the example. It's routed to the Azure firewall. Our Azure firewall is called here Azure Firewall 2 on 10.10.2.4. So Azure Firewall processes this DNAT rule and sends the request to the virtual machine 4, hence allowing connectivity from our remote network to our virtual machine. In terms of how this looks like, as the example, you can see here the listening port of our Azure Firewall 2, as this example on port 80. This is the private IP address of this firewall. The private IP address of the virtual machine form. This is the translated address, and then the translated port. So this we're able now for the second use case to allow this hybrid connectivity, and also to support the situations, the use cases where you have non-routable networks. So with that, we've covered the overview of the private IP DNAT within Azure Firewall. We've seen its use cases, its benefits, and in the next section now, I'll hand over to Gustavo for the demo. We'll also go through, there's some scenarios we've set up for you. You'll also be able to see how the logs look like. Gustavo, over to you.
Hey, Andrew, thank you. Can you see my screen?
Yes.
Great. Hey everyone, thank you all for joining today. So I'll be running the demo of this environment. And to start with, I would like to just go real quickly through the blog that Mention was talking about. So this feature is currently in public preview. And this is the blog where you can, go through the configuration and see these diagrams that we are covering here. You can also see the description of the resources that we used to demonstrate in some of the logs at the end, just to understand how it looks like, right? So this is just a blog. I highly recommend you all to take a look at this webinar here. But yeah, and then for the demonstration, we created an ARM template, which is published in our GitHub repo. And if you want to try the same environment, you can all go to this repo and deploy this ARM template. This ARM template, in this repo, you will find basically 3 files. One is the JSON with all the resources that will be deployed. And then there are 2 PowerShell files that we need to run on 2 of the VMs just to configure the website, so you can do exactly the same thing that I will be doing here on this demo. So just a quick view here. As I said, the PowerShell is just a simple PowerShell command to install IIS and make some configuration. The ARM template has all the resources. Here we are not using VPN, we are using VNet peering just to save some costs. And then, with the VNet peering, we can easily reproduce the same behavior of non-routable networks. So that's the reason why we've chosen using this environment here. It's really, easy to use this template and deploy it. But yeah, the link will be available in if someone can just put in the chat here. I really appreciate it. Okay, so once everything is deployed, this is how your Azure subscription will look like. So let me just order these by kind of resources. So we'll have 5 VNets, right? We have spoke VNets, we have hub VNets, and I created one called branch VNet. This branch VNet will be used as the non-routable network. If we go here to the hub VNet one and just use these diagram to take a look and see how it works. Where is the diagram? Here. Okay. We can see the connections. So as I said, right, we have the hub VNets. The hub VNets are connected between each other. The hub VNet 1 is also connected to this branch and then connected to the spoke VNet 1. We have another VNet here, which is the spoke VNet 2, which is connected to the hub VNet 2, but it's not showing up on this diagram. But there is this fifth VNet where we have our VMs deployed. Going back here, we have 3 VMs. All 3 VMs are Windows VMs, and the VM1 is being used as a client machine only. Then VM2 is the website for the overlapped network, and then the VM3 is the VM for the non-routable network. And we will demonstrate, the access between them. In the Azure policy, the firewall policy, right? What we have here, we are only using DNAT rules. One thing to mention is that Private IP DNAT rules is currently available only for standard and premium SKU. It's not available for basic. It's in public preview. It may or may not be available for basic. We're not sure yet. But it is available for standard and premium. This deployment will deploy a standard firewall. And these are some of the rules that you will see once the deployment is ready. So we have 5 DNAT rules here. The first one is using the public IP address of the firewall and then translating to my VM1, which is the 192.168.0.4. And then the other 4 DNAT rules are rules using the private IP address of the firewall, right? 10.10.0.4 is the IP address of the firewall. And that's the same IP address that will show up when in the Azure portal when you finish the deployment of your firewall and you go to the overview page. That's the IP address that's going to be showing there. One thing to mention here is that we are not able to add multiple private IPs to the Azure firewall, right? So let's say, for example, if you have an application, let's say 2 different applications running on port 80 and you want to have application number 1 going through one private IP and then application number 2 going through another private IP, that's not possible. We can only use the private IP which is automatically assigned to your firewall once it's deployed. At least that's how it is right now. And then we use the private IP of the firewall. We have different translated IPs in the backend. I just renamed these rules to be easy to understand. So these 2 are for are rules to the VM2, one using HTTP, another one using RDP, and then I have the configuration of the ports here, right? And the same thing for the VM3. One thing that let me show you first the VM1, right? So I will go to my VM1. This is the VM that I'm using as a client VM. So let's just make sure WinVM1, and that's the IP address of the VM 192.168.0.4, right? In order to so in an overlap scenario in Azure, right? We would not be able to route traffic from overlapped VMs without doing something like NAT, right? And then what Azure Firewall is allowing us here is really to create a bridge between these 2 overlapped networks. So if I try to connect to the other VM using 192.168.0.4, I will never be sent to the other network. So in this way, I need to use the DNAT rule that I just showed you guys. And in order to, to connect to that VM, let me just go here. I'll be using the Azure Firewall IP address 10.10.0.4. That one is using the port 80, so I'm not specifying any other port here. And then once I connect it, I'll be able to see, hey, welcome to the Overlap Network website, host name of the VM, WinVM2, IP address 192.168.0.4. Oh, okay, that's an IIS website. You can put whatever you want there. Okay, but then we can also have show the remote connection using the other DNAT rule that we have establishing connection to that VM. And then if I type here host name, I'll see I'm connected to the WinVM2, and the public key the IP address of that VM is also 192.168.0.4. So if we can see here, both VMs are 192.168.0.4. So by using the Private IP DNAT on Azure Firewall, I'm creating this bridge between two overlapped networks, allowing different resources, different machines talking to each other, even though they have the same IP addresses, right? So this is one of the use cases that we receive. We got as a feedback from customers, like, hey, sometimes we have these scenarios where we are, acquiring new companies, and they already have their infrastructure there, and it's impossible to change all the IP addresses. I mean, not impossible, but it's time taken, right? And they need a solution to create this connection between the two networks right away. So that's one of the challenges that we are able to overcome with this feature when we have these overlap networks. Okay, so how the logs look like, let's take a look here in the logs. So let me go to my private, actually to my firewall hub VNet 1, and then I'll go here to the logs. Let me close this, and let me type here AZFW, net rule. I'm not doing any specific, let's do the last 4 hours. And let's see what we get here. So in these logs, as I only have, some DNAT rules, what we are seeing here is, hey, the source IP is 192.168.0.4, which is the IP address of my client VM. And then this is connecting to the 10.10.0.5. This is one thing that it's interesting to talk about, because on my DNAT rule, I have the 10.10.0.4, which is the IP address assigned to my Azure Firewall, but then underneath I have multiple instances of Azure Firewall. So in the logs, we will see the IP address of the instance and not the VIP being used in front of the Azure Firewall instances, right? So that's something that we need to talk about and make it clear. Sometimes you'll see the .5, sometimes you'll see a .8. It's going to be whatever IP address is assigned to your instances, right? Then the destination port 80, that's the same one that's configured on the DNAT rule, and then the translated IP addresses. This one is 10.10.2.4, which is the private IP address of my second firewall, and the translated port 80, and just a little bit more information about the rule. So this is how the logs looks like on firewall number 1. If then I go to the firewall number 2, I'll see something a little bit different, because then I have another firewall performing a different DNAT rule. And before I show the logs, let me show you how the rules here look like. So here on the firewall 2, I only have 2 rules, right? The first one is an HTTP to the VM2. And here I have a slightly different configuration. So the source is only accepting connections coming from the Azure Firewall number 1 subnet, port 80, protocol TCP, destination 10.10.2.4, which is the private IP of the second firewall. And then the translated IP address is the 192.168.0.4, which is my my website that I just demonstrated here, right? So this is how the rules look like. Let's take a look at the logs. So let me just close this and type, let's do last 4 hours, is if WNet rule, and run. Okay, and then in this case, I can see a difference here in the logs, right? So the source IP will be the IP address of the Azure Firewall number 1 instance. The source IP, the random port being picked by the Azure Firewall number 1. Then the destination IP here is 10.10.2.7. Again, this is different because this is the IP address of the Azure Firewall number 2 instance, right? And not really the VIP of the firewall number 2. And then the ports, and then the translated IP here is the 192.168.0.4, right? How do we know what are the IP addresses assigned to our instances? There is nowhere in Azure where we can find that information. You will need to know that this IP is part of your Azure Firewall subnet, and at that moment, that was one of the IPs assigned to an active instance. So that's good to keep in mind. There's no way to find what are the active IP addresses assigned, and unless you come to the logs and see what are the IP instances being used here. Okay, so with this, we cover the overlapped scenarios. We do need to have 2 different Azure firewalls in this case, because number 1 will perform the DNAT between the source VM and the second firewall, and then the second firewall will perform the DNAT between the Azure Firewall number 1 and the translated VM or the destination VM, right? Okay, so let's go back to to my Windows client VM, and now actually before going back to the Windows client VM, I want to show this. Okay, so since we are going to talk about the non-routable network, I think it's fair to show you what are the effective routes that we have in our VM1, right? So if I go to the network interface assigned to my VM1, and then I scroll down here to effective routes, I will see all the routes that my network interface is automatically learning. Like, right, it could be a route being assigned via UDR or a route being assigned via system route. As you can see here, there is no UDR. All the routes are default assigned, so it means they are like system routes. And we can see that I do have these 2 that are virtual network. The first one being the 10.10.00/23, which is the address range of my hub VNet 1. And then the 192.168.00/24, which is the address space of my spoke VNet 1. So I don't have here any routes to the branch VNet, right? Which is the 176.16, whatever, 172.16, right? This one is a internal thing, which the next hop is none. So this one is not making the routes to the branch VM. So this is one thing that's important to mention. We are not using any UDRs, and that's, of course, in Azure, it would be easier to just create a UDR and define the routes. But then thinking in an environment where you have like on-premises network trying to communicate with something on Azure, and those are like non-routable, you're not able to create routes on that, you would be able to use the Azure Firewall and create this DNAT on the private IP to create the bridge to the other network, right? So just going really quick back to the policy. So here in the policy, again, we have the bottom 2 rules are for the non-routable network scenario. So we have here to VM3 on HTTP, to VM3 on RDP. Source IP address is the address range from my spoke VNet 1. Then I have here the ports. Protocol destination will be 172.16.04, which is my branch office website, right? Then if I go here to my Windows VM1, and then let me open a new tab. I'll do 10.10.0. Hold on a second. It's hanging a little bit. But here I need to inform the ports, because if I just use port 80, I'll be sent to the VM2, but I want to access the VM3. So I'll be using port 8080 here, and then I hit enter. Welcome to the branch office website. Host name WinVM3, IP address 172.16.04. That's the same thing for, let me show you guys. I have here, I'm connected using RDP. If I just type in host name WinVM3, IP configuration 172.16.04, right? So again, using the private IP DNAT, I'm able to create this connection between VMs that are in networks with no routes between them, right? So that's a good, another good scenario where, we are seeing customers using this feature for and helping them achieving, or creating this bridge between networks that are, they have some challenges creating routes between them. Let's just take a look at here on, the logs will not change really. We can go back and see, hold on a sec. Okay. We can go back and see the logs, but the logs will not really change, right? The same example that I show for the overlap networks is applicable to multiple networks, right? So right now I'm filtering by AZ, FW, net row, and then just running here again. Let's see what we have. Most recent connections. So this one is showing the connection on these non-routable network, right? So again, the access coming from my 192.168.04 Win1 VM to the Azure Firewall IP address, Azure Firewall number 1 IP address, and on port 8080, translated IP in this case 172.16.04 on port 80, right? So the logs will not change. The big change here is on scenario number 1, where we have the overlapped networks. We need to have 2 Azure firewalls to perform the DNAT twice. And on the non-routable network, we only need to have 1 firewall, which is going to perform the DNAT between the client subnet and the branch of subnet without any direct routes. So yeah, that's pretty much it for the demo. The configuration itself, you guys could see it's not rock science, but I highly recommend you playing with this environment to have a better understanding and maybe make changes, to make it closer to what you may have on your side. This template here will really help you on creating everything easily. So you just need to, you can easily use Azure to deploy it. So if you go to Azure and you use this option here, deploy a custom template, you can just, build your own template and then load a file. You will select the file that you can download from our GitHub and you'll save it. Once you save it, you can use an existing resource group or just create a new one. You have to inform the password. This password will be used for all 3 VMs that will be deployed. I need to, we can make some improvements on this template here. There's no need to change the networks. But yeah, once you click next and you start the deployment, everything will be deployed within a couple of minutes. and that's it. You're ready to play with this environment and start using it and get a better understanding of how the Private IP DNAT works. All right, so that's it for the demo, and we'd like to open the floor for Q&A.
Great. Thanks, Gustavo and Andrew. The team's been great with answering questions. As of right now, all the questions have been answered in the chat. So I think we'll move past the verbal Q&A and into the closing. So with that, I'd like to thank you, Gustavo and Andrew, for being our guests and for sharing the great information with our community. Also, thank you to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/security-community. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/ans-community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.